Okay. Let's get this thing focused. All right, so this is problem 37. Chapter 18, it says a 3 centimeter tall object is 15 centimeters in front of a concave mirror. It has a 25 centimeter focal point. So we're going to try to find the image distance. So we're going to use the mirror equation, which states that the reciprocal, or 1 over the distance of the object plus 1 over the distance of the image, equals 1 over the focal point. So we're solving for d sub I. Therefore, we need to get it on a side of the equation by itself. So we can essentially move the object distance to the other side. We get something like this: 1 over d sub I equals 1 over focal point minus 1 over object distance. And then we just take the reciprocal of that. We get the image distance equals 1 over f minus 1 over object distance. Okay, so now all we have to do is plug in the numbers. And then we get 1 over, since it's centimeters, we have to convert it, 0.25 minus 1 over 0.15. We calculate that, and we get a negative 0.375 or 38. We'll round up. So that's the image distance. So it's going to be 38 centimeters this side of the mirror. Now the height we're going to get from the magnitude, which basically says magnitude equals height of the image over height of the object, which also happens to equal negative distance of the image over distance of the object. So we're going to solve for HI, so we're going to basically throw out the M. And if we do the simple algebra, we get image height equals negative distance of the image over the distance of the object, all times, I don't know if you have to do that, I just like to do the parentheses, all times the height of the object. We plug in those numbers, we get negative 0.38 over 0.15 times 0.03. Because it's 3 centimeters. We do the math on that, and we get, there's a correction. So it's negative 0.3 as the image distance, but it's a negative of the negative, so therefore that's positive. So if we do the math on that, we get basically 7.6, so 7.6 centimeters tall. I'm going to make a distinction that these are separate answers. Okay, so that's our two answers. And if we tried to trace it, I'm going to just do a rough job here. So this comes in straight, very unstraight. Then it bounces to the focal point. And then we have one from the focal point bouncing straight. And so we basically follow this. We follow this. And they're going to cross somewhere over here. The image is going to be taller, and since it's not really intersecting, it's going to be a virtual image.